Professor Wergely, we just got done implementing counter thread. I'm going to show you how to stop a thread when it's running and when the user closes the window. You'll want to do this if you implement threads for any of the challenges or your final project, or if we're talking about on the final exam. If I go back to the docs real quick, there used to be this stop method. You'll see this is deprecated. Okay, since it's deprecated, we should not be using it. You'll want to use proper programming techniques. You'll see this method is inherently unsafe. Stopping a thread with the thread.stop causes it to unlock all of the monitors that it has locked. Okay, and some other things. Okay, you want to read this. This is a good quiz question. Why should we not use the thread.stop method? Why is the thread stop method deprecated? You can probably expect to see that on a quiz or on the exam. It's important to know why you should not use the stop method. Okay, suspend, all of these are deprecated. You should read about this. These are good quiz questions. These are good interview questions if you're going to get a job. So how do you stop a thread? You'll think it's pretty basic, but this is how you do it. I have a Boolean variable, and basically in this for loop, we'll just say if stop is true, then we're going to return. Now, what is return? Now, I could do break. Yeah, I could do break. Break will exit this for loop and go to the next line. Now, there's nothing after this for loop, so technically the method would return and it would be over. But let's say we had some code over here. Let's say we had another system.out.println, end of thread. Let's just assume we had that there. Break will run this line of code. If I do return, it's not going to. It's going to return the method. So it's going to immediately stop. Okay, it's going to immediately stop here and return. Okay, it's just going to return. It's not going to run this line of code. The other one that you'll see frequently used is continue. Now, continue will technically just skip one iteration of the loop and continue to the next one. So this is not going to stop it. I could use break, but it's going to run the rest of the code. And you'd only want to run the rest of the code if you finished whatever you were doing before. So break is not recommended either. I recommend to do a return, which stops immediately and does not continue executing any of the code. And I'll leave this print statement just so we can see that happening. So basically, if the Boolean variable is equal to true, break out of this for loop and return the method. Once this run method is finished executing, okay, once it's finished executing, which means it reaches the end block here, then the thread is destroyed. Okay, so once the run method is finished executing, the thread is destroyed. If I open up the slides, okay, so if I go back a lecture and open up the slides, you'll see that being talked about in the thread lifecycle. You'll want to know the thread lifecycle. Just like if you learn Android, you want to learn the Android lifecycle for Android apps. The thread lifecycle is very important. So we have 3 different states. We also have 3 different states while the thread is currently running. The 3 states are created, alive, and terminated. So you'll see whenever I instantiate the thread class, which I'm doing in the code here. So if I go back to the controller, I'm instantiating the thread class, but you're going to say, Professor Wergeles, I don't see the thread superclass here. Remember, counter thread extends thread. So everything that was in the thread superclass is now in counter thread. And you're going to say, well, is it true that everything's in there? No, technically not everything. All of the non-private members are inherited. Okay, that's going to be on the final exam. You got to know inheritance very well. So when I do it extends, that's inheritance. This is the superclass. This is the subclass. So thread is the superclass. And I'm inheriting all of the non-private members. So when I come back to the controller and instantiate counter thread, technically I am instantiating the thread superclass as well. So I'm creating a thread when I instantiate the thread superclass, but it's not alive yet. It's just created. I need to call the start method. You'll see start causes the thread to call its run method. The main thread will then start this thread and make it alive. So it's alive and running. You'll see I can either call stop or the run method returns, and then it's terminated. These are single directional arrows. Okay, so I can't go back to alive once it's terminated. And I can't go back to created once it's terminated. Once it's created alive and then terminated, it's done. If you want to use the thread again, it cannot be restarted. You'd have to create a new one and then start it up again. Okay, stop is deprecated. So the only option we have is when the run method returns. That's the only way to terminate a thread. Okay, so that's what we're doing. If I go back to counter thread 1, you'll see the for loop's running. Even if it's in the middle, I'm going to return. And if the for loop finishes executing, it'll print this out, and then the run method will return. Now, where do we set this? We're going to set this back in the controller. So if I scroll up, you'll see I have the ready method, and I have thread 1. So I can do something like this. If thread 1 does not equal null, so if thread 1 exists, then I'm going to call the stop method. So I'll say thread 1.stop is equal to true. Now you'll notice I'm accessing a field directly. This is just some test code. Thread playground is some test code. It'd be better to have a stop method and have data encapsulation so I can access the variable directly. But we're just using this as an example. So we'll say as long as thread 1 does not equal to null, okay, make sure you do a not equal to. Then we're going to set stop to true, and we're going to terminate. So let's see this run. If I don't put this if, and then I try to access the stop variable directly without calling the start method, then thread 1 will be null, and I'll get a runtime error. So you got to have that if there. So if I do start, close it, boom. You'll see stage is closing. It did one more execution. If I go back to counter thread, if I move this if statement up before the execution, it wouldn't have executed one more time. You'll see it executed one more time. If statement hits, returns, it didn't print this, and then it's done. Okay, if I move this up one line, then I wouldn't have that extra execution, that one more iteration. If I run this again, if I run this again, okay, so I click on start. Let's let it go up to 100 grand. You'll see the end of thread being printed. End of thread, there it is. If I call start again, terminate it, you'll see it did get that one more iteration. So it depends what happens first. So when I close the stage, you'll see this prints out. Then it says stop to true. With that amount of time from it printing out to stop equal to true, it got one more iteration in, and then the thread terminated. But the most important thing is the thread is terminated. This is proper programming techniques. So if you use threads on any of the challenges or your final projects, or there's a question on the final exam, make sure you know how to stop a thread. It looks old school, it looks basic, this weird if statement. This is the proper way to terminate a thread. You let the run method finish executing, and then the thread will be terminated. It will not be created again. You'll see I have two options here: call stop, or the run method returns. Stop is deprecated, so I only have one option here. And this is how you stop the thread when the user closes the window. We're going to go over, now this is a basic thread. I'm just printing to the console. There's not much to it. So it's really easy to get a thread up and running. I like Java and their threads. It's very easy to get it up and running, and the JVM basically handles everything else. But what if we want to update the UI? What if we want to use threads to do more complicated tasks? Stick with Professor Wergles, and I'll show you how to do that in the next video.